Good afternoon. We are going to take notes today on the first section of Unit 12, which is graphing trigonometric functions. Today's notes are really the background for what we're going to be doing throughout the unit as well as on the next test. So graphing sinusoids. The word sinusoid means it looks like a sine function. A sine function is continuing, it has no breaks, no gaps, and it repeats itself. So we're going to start by learning to graph the sine function. And we're going to use f of x equals sine of x. Okay, so for this chapter, you're going to need a lot of graph paper. We do a lot of graphing. A lot of our graphs are long and skinny. In general, on your graphs, you're going to want to make the right side longer than the left because you need to fit 2 periods of the function on the right and 1 period on the left. All right, so this is where your 90-degree memorized angles are going to come in handy because we're going to go by 90 degrees. Now, I'm going to do this scale today in radians. So skip every other spot. We're going to have pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, I have to go a couple more spots here, 7 pi over 2, and 4 pi. So basically we're just counting over. Now if you write the scale out, then you don't have to label every single point with the x-coordinate. In the opposite direction, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Okay, so your memorized sine values are sine of 0 is 0, sine of pi over 2 is 1, and let's go ahead and put a 1 2 spaces up and a negative 1 2 spaces down. Sine of pi is 0, sine of 3 pi over 2 is negative 1, and then 2 pi is back at 0. So this amount of the curve is 1 period. So from here to here, let me use a different color. From here to here is 1 period of the function. And sine functions repeat the same period over and over and over again. So once you figured out the pattern and the values, then you can just simply dot them in. So 1, 0, negative 1, 0. And then at the end, you put an arrow because it keeps going. So this is 2 periods of the function. That's how much you need to graph. Okay, now we're going to go backwards. So the values go backwards. We have a negative 1, a 0, a positive 1, and a 0. And then an arrow to keep going. And of course, this is 1 period to the left. All right, so you're going to be asked to analyze the sine graph. So let's start with domain. Okay, so the domain of the graph, the x values left to right, is negative infinity to positive infinity because there's no breaks or gaps. The range of the sine function, it has a value at negative 1 that repeats, and it has values at positive 1 that repeat. So my range is negative 1 inclusive to positive 1 inclusive. Okay, continuity. Well, there's no breaks or gaps, so we would say this curve is smooth and continuous. Okay, boundedness. It's bounded above, it's bounded below, so we just say bounded. This function can be described as periodic, and the period of sine from here to here is a amount of 2 pi. That's the period that repeats itself. Oh, sorry, I'm off the screen there. Repeats. Okay, amplitude. This is a new one. The amplitude of the graph is 1/2 the height of the graph. So if we go back up to our graph, we have maximum values here at y equals 1. We have minimum values here at y equals -1. So from top to bottom, it's a distance of 2. So our amplitude is half of 2. So half of 2 means that our amplitude is 1 for sine graphs. Okay, symmetry. Well, we can do the quick check. It's not even because we can't fold it in half, but if I flip it over, bottom left to upper right, the curve looks the same, which means it has odd symmetry. Now, algebraically, that means that sine of a negative angle is going to be equal to sine of the same angle, but the positive one, which helps us when we simplify stuff. So the negative simplifies out because it's an odd function. Okay, continuing down our list, we have asymptotes. There are none. There are no horizontal or vertical asymptotes. And end behavior. So with a periodic function, as you go to the right, it never settles on anything. It goes up and it goes down, it goes up, it goes down, it goes up, it goes down. It never actually rests or goes towards a single value. So when it comes to a sinusoid, there is no end behavior. There's no one thing it goes to become. All right, last thing we're going to do is extrema. Okay, so what do we have for extrema? Well, we have a y value here of 1. This occurs at pi over 2 comma 1. But there's another one over here that occurs at 5 pi over 2 comma 1. So we have the same maximum happening twice. What we do with that is, because it's the same maximum twice, we say that it has a local maximum of y equals 1 at, and for right now, we're just going to say y equals 1, and we're going to leave this a little bit alone. But it's at pi over 2 plus, so it starts at pi over 2. It goes a distance of 2 pi tip to tip. So 2 pi times n, where n is an integer. So to give when it occurs, you give the first one, which occurs at x equals pi over 2, plus whatever the period is, and then times the number n, because it goes over and over and over. Because it goes over and over and over, there's a local max, there's not an absolute maximum. Okay, so for local minimum, so we have a minimum here at 3 pi over 2 comma -1, but then we have another minimum right there at 7 pi over 2 comma -1. So it's a local minimum of y equals -1 at x equals, and then you name the first one, which is 3 pi over 2 plus, and it goes from tip to tip, that's 1 period. 1 period is 2 pi. So plus 2 pi times n, where n is an integer. And again, there are no absolute max or absolute minimums with a sine function. Let me move that up so you can write that down. All right, so the next one we're going to do is the cosine function. It's the other sinusoid. And once you learn to do a sine function, the cosine function is a whole lot easier. So this is the cosine function. We're going to use f of x equals cosine of x. All right, use your ruler. We're going to draw ourselves a nice long line. Extend mine just a little. And then you want to put it like 2/3 over to the left. Now, the nice thing about cosine and sine are they're very, very similar. They're also easy to graph using pi over 2 values or 90 degrees. So that's how we're going to number this. Pi over 2, pi, 3 pi over 2, 4 pi over 2 or 2 pi, 5 pi over 2, 6 pi over 2, 7 pi over 2, and then we're up to 4 pi. That's, of course, 3 pi right here. And then to the left, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. And we're going to skip a line and go up 1 and down 1. So your cosine function wave looks just like a sine wave, except that it starts at a different point. A cosine wave starts at 0, 1, because cosine of 0 is 1, and you've memorized that. Starts at 1, and then it looks the same. So it hits 0, negative 1, 0, and up 1. So for a cosine wave, that is 1 period. It's 2 pi, but it just starts at a different place. Let's keep going. So we have 0, negative 1, 0, up again. Put an arrowhead on it. And from there to there is period 2. All right, on the left, it goes backwards. 0, negative 1, 0, positive 1. Put an arrowhead on it. And that is from 0 to negative 2 pi, that is 1 period in the negative direction. So really, a cosine wave looks just like a sine wave that's been moved over. Okay, let's go through our list now. Domain, negative infinity to positive infinity. Range is the same. We have negative 1s and positive 1s. So negative 1 to positive 1 inclusive. It is smooth and continuous. There are no holes, breaks, or gaps. It is bounded because it's bounded top and bottom. So we just say bounded. Okay, the amplitude. Remember that your amplitude is 1/2 the height of the graph. So just like our sine graph, we have a maximum at 1 and a minimum at negative 1. That gives us a height of 2. So the amplitude is 1/2 of 2, which is equal to 1. So same amplitude as your sine function. Okay, symmetry. So looking at the symmetry, I can take this graph and fold it in half. So my symmetry for a cosine wave is even. Even symmetry, which means when you take cosine of negative theta, it equals cosine of regular theta. Now it just dawned on me, I left the negative off on the previous page. Sorry, there should be a negative in front of that. And that's because f of x, negative x, is equal to negative f of x. That's your definition of odd symmetry. Same thing here, except it has even symmetry. All right, so next on the list, asymptotes. There are none, no vertical, no horizontal. End behavior. Again, because the ends don't settle on anything, they just keep oscillating. There is none, no end behavior. So we're going to get into the extrema. Since it oscillates, there's no absolute max or min, but let's find our first point. This is our maximum here, 1. That's the point 0, 1. And the next one is at 2 pi comma 1. So our extrema, we have a local maximum of y equals 1 at x equals, and since we're starting at 0, we can just go 0 plus 2 pi, because from here to here is 2 pi, times n, where n is an integer. That's our max. Okay, local minimum. Well, I have a minimum here. This is at pi negative 1. My next one is here, which is at 3 pi negative 1. So the local minimum is y equals negative 1 at x equals, so give the first x value, which is pi, plus the distance from the first one to the second one, which is 2 pi, and everything else is a multiple of 2 pi, so it's pi plus 2 pi times n, where n is an integer. So any whole number that you use for n is going to land you on a local minimum. Okay, so those are your two basic functions and what you need to know about them. Now we're going to get into analyzing the graphs. So this is Roman numeral 3, sinusoids and transformations. Now what you'll find is many of the transformations are similar, if not identical, to the ones you already know. But there are a few new terms you need to learn when it comes to sinusoids. So first off, here's the generic equation. F of x equals a times sine of the quantity b times x minus h plus k. Notice the scalar goes outside, so it's a 1x plus or minus the translation. That's the same. And then f of x for cosine is a cosine of b times x minus h plus k. Okay, let's start with a. A is the amplitude. A is the amplitude, and the amplitude is half the height of the wave. Half the height of the wave. And when it comes into a base graph, meaning without any kind of transformations done to it, your base amplitude for a sinusoid is 1. Okay, so using the amplitude, which is going to be the a value, your stretch or shrink vertically is the absolute value of a. And the same rules apply. If the absolute value of a is greater than 1, it's a stretch. If the absolute value of a is less than 1, like a fraction, it's a vertical shrink. So that's the same, which is kind of nice. Okay, B, the period. Okay, a period is one full cycle of the wave. Okay, on your basic graph with nothing done to it, so on your base graph, your period for cosine and sine is 2 pi. Okay, so adjustments to the period would be a stretch or shrink horizontally. And you use 2 pi divided by the absolute value of b. B is the number, of course, right here being multiplied. So remember that when it's inside the parentheses with the b, it's always backwards. So if absolute value of b is greater than 1, it's a shrink. If the absolute value of b is less than 1, it's a fraction, it's a stretch. Just like how it was when we were doing our other curves. Same rules. Flip it, That tells you if it's a stretch or shrink. Just flip the b. And to figure out exactly what the period is, you take 2 pi divided by b, and that will tell you the new period. Which, of course, if you do that, it should be pretty easy, because if 2 pi divided by b is bigger, you have a bigger period. If 2 pi divided by b is smaller, you get a smaller period. All right, C, frequency. Frequency is the number of cycles out of the period. And so the number of cycles outside of a period. So again, you're going to have one cycle in your base graph. Your frequency is going to be a 1 because you have one cycle per 2 pi. Okay, so how do you calculate frequency? Frequency is calculated as the absolute value of b over 2 pi. So basically, it's the reciprocal of the period. And we're going to practice these in a second. That should make it a little clearer. Okay, D, phase shift. A phase shift is a fancy way of saying horizontal translation. And in the formula, it's the h. So if it is x plus h, it's going to go left h units. If it is x minus h, it's going to go right h units, which is exactly like what we did before. So that hasn't changed. Okay, E, vertical translation. Well, that's the same term as always. So vertical translation is the k value. So if it's a plus k, you're going to go up. If it's a minus k, you're going to go down, just like what we've learned. All right, last one of these is F, reflection. Okay, and again, these are actually the same as what they were before. If it's -1 times f of x, then you're going to reflect across the x-axis. If the negative is inside with the x, oh shoot, I made that too small. Blot that out. So if it's f of negative x, then you're going to reflect across the y-axis. And this is exactly the same as what we've memorized. Negative out front or negative with the x. All right, last section of notes is we're going to graph using transformations. So this is Roman numeral 4. Graphing with transformations. We're going to pull all of this together to make a graph. Okay, our example is going to be f of x equals 2 sine of 4x. Now, like before, you might want to have a laundry list. We need to know the period. We need to know the amplitude. We need to know any shrinks or stretches. So horizontal, shrink or stretch, vertical, shrink or stretch, and possibly a reflection if there is one. So what most people do is they use the formula and they determine this from the formula first before they even start to graph. That way they don't have to make an axis that's not labeled appropriately. Okay, so the 4 inside, it's being multiplied by x, so that's a horizontal shrink or stretch. Since it's a 4, it gets flipped, and that's a horizontal shrink by a factor of 1/4. Okay, there's a 2 in the front. That would be your vertical stretch. Because it's a whole number, what you see is what you get. So vertical stretch by a factor of 2. Now the period of the function is affected by the b value. So what you do is you take your period, which is 2 pi, and you multiply it by the reciprocal, 1/4, and that equals pi over 2 as your new period. Now, since the amplitude is half the distance of the wave, the original amplitude was 1, but this is being stretched, so the amplitude gets multiplied by 2. So the new amplitude is 2. And there are no negatives anywhere, so there are no reflections. All right, and I'm going to move my graph down a little bit because I don't have enough space here to do what I want to do. All right, we're going to draw our graph. Now here's the nice thing about doing this ahead of time. I can just put my 2 where I would normally put my 1, and I'm counting by 2's. So there's my amplitude, up 2, down 2. Now I know that the period is pi over 2. So this is how I do it. I go, okay, it's going to go here, it's going to go up, it's going to meet at 0, it's going to go down, and then it's back where it started again. So you kind of have to memorize what this first period of sine looks like. The first period of sine is always up on the diagonal and down, and that's your 2 pi. That's what you need to memorize for sine. But what's different is instead of going to 2 pi, our period is only pi over 2. So for the 0 here, I'm going to put pi over 2. And I'm going to go ahead and draw this graph in, and then we're going to label it. So it goes up to 0, down to 0. So we have to label the axis. One period is pi over 2. Half of pi over 2 is pi over 4. Half of pi over 4 is pi over 8. So 1 pi over 8, 2 pi over 8, 3 pi over 8. So we're counting by eighths. 4 pi over 8, 5 pi over 8, 6 pi over 8, 7 pi over 8, 8 pi over 8, which is pi. So again, I'm going to continue my sinusoid as so. Once you've got the right scale, we can go in the negative direction pretty easily. Negative pi over 8, negative 2 pi over 8, which is pi over 4, negative 3 pi over 8, negative pi over 4 pi over 8. And the shape is the same. It's going to go down to 0, oops, down to 0, up to 0. So there's my 1 period. And try not to make these pointy. That's not a very good curve. And there you've got. Now, if your scale is not clear, then like on a test, you would label the points, the maximums and the minimums. Pi over 8, comma 2, 5 pi over 8, comma 2. This one is 3 pi over 8, comma negative 2. This is 7 pi over 8, comma negative 2. Over here, negative pi over 8, negative 2. And last one, negative 3 pi over 8 up 2. So you would label the maximums and the minimums on your graph as well as the zeros. Okay, so we're going to do one more. Example 2, we're going to do f of x equals negative cosine x plus 2. Okay, so on our laundry list, there is no b value. There's nothing in with the x. So my period is 2 pi. That's kind of nice. There's nothing multiplied at the front. So my amplitude is 1, just like normal. What I do have, though, is a negative out front, which means you're going to reflect across the x-axis, and then a plus 2 vertical translation up 2. And do remember your your order of things. It's always the same. Shrink, stretch, reflect, translate. Okay, so we're going to use the transformations to graph this. So I'm going to give myself a nice long line here to deal with. There we go. Okay. Oh, I should have dropped this down just a little bit, but we'll figure it out. I wonder if I can still get up that high. 1, 2, nope. Okay, so we're going to do, and now we know we're going to be translating up 2, so we're going to need to have a scale here that reflects that. So we're going to have 1, 2, 3, 4, -1, -2, -3, -4. So in order to graph one that's had different things done to it, what you want to do is graph the base function without the reflection and without the translation. Just draw a cosine graph with a period of 2 pi and an amplitude of 1. So you're going to do that first. That's going to be your base graph. Okay, so this is pretty easy because 2 pi is the normal period for sine. So pi over 2, 2 pi over 2, 3 pi over 2, that's your 2 pi. 4, 5 pi over 2, 6 pi over 2, 7 pi over 2. And then going in the opposite direction, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. All right, so cosine graph normally has an amplitude of 1. So, and I'm going to use a pencil here so it's a little bit lighter. So it's going to start at 1. It hits at 0, -1, 0, and then up here. And then it keeps going, 0, -1, 0. And here, 0, -1, 0, 1. There's your base graph. It has a period of 2 pi and it has an amplitude of 1. Now it looks flatter because the scale I picked is a little bit shorter for the ones. Okay, so what we're going to do is we are going to translate it vertically up 2. So each point is going to go up 2. So I'm going to use, let's see, I'll use green. So 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So there's our first one. 1, 2, 1, 2, 1, 2. There's our second one. Now back here, 1, 2, 1, 2, 1, 2, 1, 2. So I've done my translation. So I've translated up 2. So that's your green line. And then the last one we're going to do is reflect across the x-axis. All right, so here's our x-axis. We're going to reflect across the x-axis. Now, if you I wanted to do this way. If you translate before you reflect, remember you're supposed to reflect before you translate. If you screw that up, all is not lost. However, you're going to need to reflect across the new midline. So if you've messed this up, you really should reflect first and then translate. Then you don't have a problem. But if you don't do that, then you translated, then your new line of translation is where the new x-axis is at. And that's the line you're going to reflect it across. So everything is backwards. So that's what you have to do if you accidentally vertically translate before you reflect, is you've got to do a new x-axis. Where would the new one be? And then flip it across that. So I'm going to highlight here which is the final curve, because sometimes these drawings get a bit messy. Okay, so I wanted to show you how to fix it if you don't go in this order. But this is the best order for you to go in. All right, that is all for the notes today. I know it was pretty extensive, but we covered a lot of material. Have a good afternoon.